Tutor Polly here, back with another question. Double integrals, like one integral wasn't enough. We have this expression here. What I first want you to notice is that we're integrating with respect to y first, and then we integrate with respect to x. So you start on the inside and work your way out, although you can switch it up if it's advantageous to do so. So we're going to start with the y's. So the goal here is to pretend that x's are numbers, x's are constants. They're kind of just along for the ride. We're not integrating them, we're integrating with respect to y right now. So my focus is actually on this x, and the reason for that is I wanted to give you this example. Now I imagine differentiation and integration as a vertical silo where when you go down, you're differentiating, and when you go up, you're integrating. So here, take this example, e to the 2x, where 2 is kind of a placeholder for our example, where, well, if I were to differentiate this, that's e to the 2x times the derivative of the inside, times the derivative of 2x, which is 2. So this is e to the 2x times 2. So if we were to integrate e to the 2x, what would we get? We're going to have to focus on that problem there with the 2. Well, I know the e to the 2x will be there because that framework will always be there in this circumstance, but I need to cancel out that times 2. So I'm going to do divide by 2, aka times by 1/2. So let's differentiate it now. Let's differentiate the 1/2 e to the 2x. So that'll be 1/2 e to the 2x times 2. They cancel out, and I'm left with the 1 that I was hoping for. Well, perfect. So now we have to figure out this x constant. So the integral of this is going to be x e to the xy times 1 over x. The x's will cancel out. So if I were to differentiate this expression here, this would get me what I started with. The derivative of this is e to the xy times x, and that's what we started with. So this is our integral. The bounds are from 0 to 1, and they are y bounds. We're going to plug them in only for the y's, okay? So it's e to the 1x minus e to the 0. E to the 0 is 1. Now we're integrating with respect to x. This is easy at this point. The integral of e to the x is e to the x. The integral of 1 is x, okay? And now we're just plugging in the 2 and 0. There's the 2, and now we have the 0. E to the 0 will cancel out, so you have e squared minus 2 minus 1. That's e squared minus 3. I hope this helps.